We're going to walk through 5 very common general antiderivative examples, and I'll show you everything you have to think about when you're doing these types of problems. In these examples, we are going to find the most general antiderivative of the function. That means that we're going to have to include a plus c with our answer. The first example that we're going to look at is f of x is equal to 4 plus x squared minus 5x cubed. Just to make things easier, over here on the right, I've written down the function x to the n, as long as n is not equal to minus 1, and its antiderivative x to the n plus 1 divided by n plus 1 plus c. In this first example, I want to begin by rewriting our function little f of x as 4x to the 0 plus x squared minus 5x cubed. That x to the 0 is going to help us learn how to find the antiderivative. If you're finding the antiderivative of a little function f of x, then that antiderivative is typically notated as capital F of x. So we're going to say capital F of x is equal to 4 x to the 0, and then we're going to add 1 to our exponent and divide by that exponent. Now let's do the same thing to the next term. This is x to the 2 plus 1, all divided by 2 plus 1, and then we have minus 5x to the 3 plus 1, all divided by 3 plus 1, and then we have to add a plus c. This gives us capital F of x is equal to 4x plus 1/3 x cubed minus 5 over 4 x to the 4th plus c. And that's our final answer. In our second example, we're given the function little f of x is the 4th root of x cubed plus the 3rd root of x to the 5th. I chose this one because I want to show you that before you find the antiderivative, it's best to rewrite the function. So we're going to rewrite f of x as x to the 3/4 plus x to the 5/3. Now we can find the antiderivative much easier. Our antiderivative is capital F of x, and then it's going to be x to the 3/4, and we're going to add 1, and then we're going to divide by that exponent, 3/4 plus 1. And then we're going to do the same thing to our second term. This is x to the 5/3 plus 1, all divided by 5/3 plus 1 plus c. Let's go ahead and simplify this. 3 over 4 plus 1 is 7 over 4. So this is x to the 7 over 4, all divided by 7 over 4. And then our next term is 5 over 3 plus 1. So that is 8 over 3. And then we divide by 8 over 3, and we have our plus c. And then we're going to write our final answer in a little bit easier form. We're going to take the 1 over 7/4, and we're going to write it as 4 over 7, x to the 7 over 4, plus 3 over 8, x to the 8 over 3, plus c. And there's our answer. In our third example, we're given a function little f of x is equal to 5 minus 4x cubed plus 2x to the 6th, all divided by x to the 6th. Because we have one term in the denominator, we can break up our function into 3 separate pieces and then write each piece as x to a power. Doing this, we can write f of x as 5 over x to the 6th minus 4x cubed over x to the 6th plus 2x to the 6th over x to the 6th. You can only do this when you have one term in the denominator. We now need to rewrite this so that each term is x raised to a power. This is f of x is equal to 5x to the minus 6 minus 4x to the minus 3 plus 2. Now we can go ahead and take the antiderivative. Our antiderivative, capital F of x, is equal to 5x. Now we're going to add 1 to the exponent, and we get minus 6 plus 1, all divided by minus 6 plus 1, minus 4x to the minus 3 plus 1, and we divide that by minus 3 plus 1, and then we have a constant 2, and we're going to multiply that by x, and then we add on our constant c. Let's now simplify this. This is capital F of x is equal to 5x to the minus 5, all divided by minus 5, minus 4x to the minus 2, all divided by minus 2, plus 2x plus c. Now we just have to simplify it once more, and we'll get our answer. Capital F of x is equal to minus 1, all divided by x to the 5th, plus 2, all divided by x squared, plus 2x plus c. And there's our final answer. Our last two examples are different than our first three because they involve exponential and trigonometric functions. In example 4, we're given the function little f of x is equal to 5e to the x plus 2 divided by x. We don't have to simplify this function at all. We can just go straight ahead and take the antiderivative. Capital F of x is equal to 5. The antiderivative of e to the x is just e to the x. So we have 5e to the x plus 2 times 1 over x, and the antiderivative of 1 over x is the natural log of the absolute value of x, and then we add on our plus c. And there's our answer. In our fifth example, we're given a function little f of x is equal to 2 sine x minus secant squared x. We also don't have to simplify this one before taking the antiderivative, and we can just go ahead and take it. Capital F of x is 2 times the antiderivative of sine x. The antiderivative of sine x is minus cosine x. And then we subtract off the antiderivative of secant squared, and that is tangent x. And then we add a plus c. We can rewrite this as capital F of x is minus 2 cosine x minus tangent x plus c.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.